here's another example of dynamic programming in a problem that's a little bit more involved.
So let's consider the following scenario. Suppose that you are a YouTuber and you upload your vlogs onto YouTube for people to watch, and you gain money from those vlogs which you use to, well, survive as a YouTuber. Now let's do a very simple assumption that the way that YouTube gives you the money for your videos is according to how long your videos are. For example, if your video is a minute long, YouTube might give you a certain amount of money. If your video is instead 2 minutes long, YouTube gives you a different amount of money. The money might not go up in a linear rate, it might not follow any pattern whatsoever, but you do know how much YouTube gives you for a video of a certain length. It might look like a table, sort of like this. And we'll also assume that the videos you upload are in whole minutes, so like none of like 2.5 minute videos or anything. And so let's assume that in the previous week you were recording, some amount of videos. Let's assume for concreteness, let's say you've recorded 20 minutes worth of footages ready to be uploaded onto YouTube. However, you don't really just want to upload all this 20-minute worth of footage into one video. What you really want to do is you want to try to maximize the amount of profit you make. You want to split your videos strategically so that you're uploading and getting the maximum amount of profit out from YouTube. And maybe uploading the whole 20-minute into one big video isn't the best way of doing so. I mean, who even watches 20-minute videos nowadays? Who do you think you are? Vsauce? So there's many ways you can sort of split up your videos. Maybe you might want to split your videos into 5 videos of 4 minutes each, or maybe you want to split it into 2 videos of 7 minutes and then another video of 6 minutes, or you might be really crazy and just upload 20 videos of a minute each. But what you really want to do is you want to try to upload your videos so that you get the maximum amount of profit back. So assuming that your profit depends on the length of the videos that you upload, what's the best way to split your videos up and upload them to YouTube? Now this sounds like an optimization problem, right? Because you have a certain situation. You have some amount of videos that you have, some raw footage that you have, and what you're trying to figure out is how you can chop these footages up so that you maximize your profit. So there's a clear objective there, that you're trying to maximize the profit given the footage that you have and given the amount of money you'll make for each of the videos that you upload, depending on the length of those videos. And so as you can see here, this is an optimization problem because we have a clear objective. We want to maximize the profits from our videos. And also there is some constraints to it because you have got only a limited amount of videos that you can upload and split and play around with. And you also know how much each videos will be giving out as a profit. So that is a question that we want to solve. And the question is, how can we solve it? Now, the easiest method that I can do so is by brute forcing the whole thing, by just checking every single combination of videos that I can upload to YouTube, checking the amount of profit that each of those combinations makes, and then comparing the profits, finding the maximum profit. The problem with that technique is obviously it takes a really long time, and it's not really ideal to do that. So what we really want to do is we want to be a bit clever with how we find our solutions. And so the question is, how can we solve this? Well, let's try to, see the problem in a bit of clearer manner. I'm gonna write a couple of stuff down that might help us visualize the problem a bit better. So what we have, the data that we are given is a table. The table will contain the amount of minutes in the video and how much money you will get. So the video might say, for example, if a 1 minute video, you're gonna get 1 unit of money, for example, and then maybe a 2 minute video will get you 3 units of money. 3 minute video gets you 7 units of money. 4 video maybe only gets you 8, and so on, up until however far we need to go, right? And suppose you have some amount of footage. So for this case, maybe we have 20 minutes worth of videos, right? 20 minutes worth of footage for our video. Now, the way that I'm going to try to come up with this solution is to use the idea of having subproblems in some certain way, right? So using subproblems, we're going to try to divide a big problem that we have of, for example, finding like the optimal way to divide a 20-minute video or the maximum profit that we're going to get by dividing it down into smaller subproblems and trying to solve this big problem using those smaller subproblems. A very good but maybe a weird way to think about it for this problem is, suppose we already have the solution to the maximum profit that we can get for 19-minute videos or 18-minute videos and all the way down to, well, a video of 1 minute long. Suppose we have all of the maximum profits for all of these cases already. How can we use all of these answers to help us find the maximum way to split the 20-minute videos that we have? So here I'm going to draw a line, and this line will represent the 20-minute worth of videos that we have. Let me just maybe number it 0 to 20, just so we can like have a clear idea of what we're trying to do here. Now, suppose I want to split this 20-minute video into smaller chunks. Well, one way I can think about this is I can first place an initial split somewhere along that 20-minute video. Let's suppose I call this first chunk maybe up to k minutes, where k is a number. For this case now, let's assume k is a number between 0 and 20. And in fact, I am going to say that suppose we can split this first video right at 20 minutes. So I'm going to make this an inclusive of 20. This is like just not bother splitting the video at all, just uploading the whole 20 minutes at once, right? Or having k right here, which means the first cut is around the 20 minutes, right? But you know what I mean. So suppose this is our k. K is just like the first place where we split our video. So suppose here we can upload this video as one of the videos, and these bits here, we can split them further. Now the question is, what is the amount of profit that this split will make? Well, this bit here is uploaded as one video, right? And how much will this video of length k minutes be cost? Well, this will be determined by this table. So suppose this table is represented by m of t. This will mean the amount of money that you get if you upload a video of t minutes. This bit will get you the money of m of k, like so. Now, what about the rest of the videos here? This will be worth 20 minus k minutes, right? So the question is, how else should I be able to split this 20 minus k minutes to maximize the profit? Well, let's go back to our assumptions of how we're going to be working out this problem. Well, what I've assumed so far is that in order for me to find the maximum amount of money, the maximum profit I can make with 20 minutes worth of videos, what I'm assuming is that I already know all these solutions for 90 minutes, 18 minutes, so on down until the first video only having 1 minute long. So I want to find how much profit I can make off this chunk of video. I can just look up one of the solutions that I already had, how I will shop the videos in one of these solutions I already know, and just use it here. So with the amount of footage for 20 minus k minutes long, what I can do is I can simply look up one of the cases here. And so I can find that the maximum amount of profit I can make with this chunk of video will be equal to one of these solutions, which I will call max profit, representing the maximum amount of profit given a certain minute of video that I upload. And this will be the max profit of 20 minus k as such. But now remember that k can be anywhere between 0 exclusive to 20 inclusive. And so I want to find where I should place my first k, where I should place my first video, so that I can get, well, the maximum profit with my 20-minute worth of videos. So what I can find is that max profit for 20-minute worth of videos will be whatever the maximum is for having the first video of k minutes long, plus whatever the max profit is for the rest of the footage, I haven't divided up as I vary k, and k can be varied from 0 all the way to 20 as such. And if I want to find the maximum profit that I can make from n minutes worth of footage, this will be the same as finding the maximum amount of the first video having k minutes long plus the maximum profit for the rest of the chunk, or n minus k, as we vary k from 0 to n. And we want to find what value of k gives us this maximum value, and whatever this maximum value is will be the maximum profit we can make from having n minute worth of videos. And the important part here is that we can find all the smaller cases up right before n in order to get the answer for n. And so here you sort of see that there is some sort of a recursion sort of thing going on here, because in order to find the solution to a certain problem, you have to deal with the subproblems right here, right? Because in order to find the maximum profit for n minutes worth of footage, you have to find the maximum profit for n minus 1 worth of footage, n minus 2 worth of footage, and so on down. And so you have to be able to write the function that finds what this is. And so your function, you're going to have to make recursive calls, and you have to do some recursion in order to find all the previous numbers up to n in order to use those answers to find n. And because there's also this recursion going on, and in fact if you think about it carefully enough, there will also be sort of overlaps between each of these problems. I'm not going to bother drawing the tree, but you can sort of convince yourself that this will be the case. And because there is subproblems, these subproblems sort of overlaps, then you can use dynamic programming here. And one other thing is that because we are having to deal with recursion, it's also important for us to establish a base case. In this case, 1 minute could well act as our base case, but we can go even simpler and consider how much profit we make when we have 0 minutes worth of videos, or when our n equals to 0. And as you can see here, if we have 0 minutes worth of videos, well, we can't really make any profits, and so this can really be our true base case. And so we can write down that maximum profit when n equals to 0 is just going to be 0. And that can be where our recursion starts, when this bit doesn't call max profits any further time. This will be our base case. And any values of n above 0 will have to call maximum profit at some point because of how we define, well, this bit here. But that's perfectly okay, because now at least we have a base case. We know that our recursion will stop somewhere. So what will our function really look like? Well, our function, the function that we have, will be very similar to this. I was sort of a bit sloppy here, but what we really should have as a function will be a function that I'm going to really just call max profit, which will take in a certain value of n, where n is just how many minutes worth of footage that we have. But another variable that we need to take in is this table, because this table is what determines how much money we can get for a video of a certain length. So somehow I have to include this table into my parameters as well. So I have an n and I have an m, and this is going to be the function that we will be writing in our Python code. As you can see on my screen right now, I have a certain array which I'm calling m up on the screen. M is an array which has got the amount of profit I will get if I upload a YouTube video of a certain length to YouTube, right? So for example, if I upload, in this case, if I upload a 5-minute video to YouTube, I will get 10 units of money, $10, £10, whatever, right? And as you can see, the way that this is done is because fifth element in the array, or actually the sixth element, because this first has got an index of 0, you count 1, 2, 3, 4, 5. The fifth index is in fact just 10, right? And if I can check, if I upload a 0-minute video on YouTube, I'll just get 0, right? So that's just for the purpose of you knowing what m actually looks like. And so what I'll do first very quickly is just write out the solution normally without using dynamic programming, so you sort of have an idea of what the recursive programming normally will look like. So I'm going to define the function called max profit. Max profit will take in two parameters, as I said, n, which is how many minutes worth of footage that you have, and m, which is that list up there. So first we have to deal with the base case, and as I said, the base case in this case will be when we have 0 minutes worth of footage, right? And so we can say if n equals to 0, we just return 0, because if you have no footage on YouTube, you're not going to make any money, and that's just the hard fact of life, right? Else, this means in any other case that we actually do have some footage. Again, I'm not going to consider when n is a negative number, it's not a whole number, we're just going to ignore all of those things out there, right? So what we have to do is we have to find all the possible shopping. And the way that we did so is try to maximize the amount of money that we can make given where we shop our first video, given where our variable k was. And so the way I'm going to do this is by first creating an array. I'm just going to call this possible profits, right? And I'm going to initialize this as a blank array at first. So we're just going to add values in, right? And so now what we're going to do is we're going to do a for loop, right? We're going to say for k in range from 1 up to n plus 1. Explanation of why I have to do this. This range will give a list of numbers going from 1 all the way to n, which matches the inequality that we have, because k can vary anywhere from 0 exclusive all the way to n inclusive. And so what I'm going to do is I'm going to find the amount of profit possible in this case, which will be equal to m at position k, plus the max profit that we can make for video of length n minus k, right? And so this is the amount of profit that we can potentially make if I shop the first place at k minutes, and then the rest of it just however we can divide it to maximize the amount of profits according to previous solutions. And that's where I call the function itself. Oh, and I also have to include m in my parameters like that as well. And now that we have the maximum profit, we can add this profit to the possible profit. The way you do so is by doing possible profits dot append, because it's Python, p like that. And now by the end of this loop, we're going to have all of the possible profits for each of the place we put our k, our initial shop in. To get the maximum profit is I just do return max of possible profit, like so. And so if I do max profit of, for example, let's just say 3 and n, because I have to include the list there as well, I get 7, which determines the maximum of profit I can make with a 3-minute long footage. In this case, it looks like so, because I can just upload all 3 minutes up. If I load a minute or 2, I only get 4. If I upload any shorter, I get even less. You can work it out. You can sort of see this by eye. If I want to find how much profit I can make with, just say, 20 minutes worth of footage given that data. More importantly, I want to also time this, just because we're going to compare it against our fixed code later on. We can get a maximum profit of 63. I'm not entirely sure how that came about, but maybe you might be able to see it, right? But for this case, let's keep that in mind. The more important thing I want to point out is the amount of time that it takes. In this case, it took, I'm going to take the wall time, I think that's most accurate, 567 microseconds. So let's keep that in mind. So what I want to do now is I want to try to be better than what I was before, and the way I'm going to do so is by making this code more dynamic programming like, and using dynamic programming in it. And if you remember, the concepts of dynamic programming is that we save all the answers to the questions that we have already done. And the way we're going to do so is by creating an array to store all those answers that we already have. The approach I'm going to take is going to be a bottom-up approach. So what we're going to do is we're going to work out the smallest case from when we have 0 minutes of videos up to 1 minute worth of videos, and then 2 minutes worth of videos, all the way up until we have n minute worth of videos, which is the actual answer that we want, right? So let's give it a go. First, I'm going to create the storage, right? So I'm going to call this the profit storage, and it's just going to be a blank array, because of course it is. We're just always going to do that. Now, what we have to do is we have to loop over each value. So we have to start from having 0 minutes worth of videos all the way up to having n minutes worth of videos. So let's just say 4 minutes in range n plus 1, what this statement is saying that each time we have the loop, it's going to loop from 0, which is the first element in range n plus 1, all the way up to n. So this range n plus 1 will have numbers 0, 1, 2, 3, all the way up to n, which is what we want to calculate. So the inside of the code is going to work almost exactly like how the recursive code works to find the maximum amount of profit. So first we have to check if minute is equal to 0. If you have 0 minutes worth of footage, then we know that the maximum profit, which I'm going to call P, will just be 0. Else, minutes is not equal to 0. We actually have some footage. We're going to have to find the maximum amount of profit that we can make for that particular case. The way we're going to do so is first, similar to what we did before, we're going to have an array called potential profit. I can't remember what I called the array in the first time, so I'm just going to call it potential profit, changing the names. So in here, we're going to have to do another for loop. In this case, I'll say for I in range from 1 minute all the way up to, in this case, it will be minutes plus 1. Again, this range here will loop us through the numbers from 1, 2, 3, all the way up to how many minutes we are doing. In fact, let's keep it consistent from before, because I remembered I used this variable k here. And so here we work out the amount of profits that we are going to make if we shop the first place at k, and then deal with the rest according to whatever it was good, according to the answers that we already had. So what I'm going to do is I'm going to say that I'm going to do this hopefully not too confusingly. I'm going to say potential profit dot append, and what we're going to append will be m of k. So this m plus k will be the amount of money we get if we have a k minute worth of video. But then we still have the rest of the videos, which will be of length of whatever the minutes is minus the k. And we know that that answer, the maximum amount of profit that we can make from that section of the video, will be stored in the profit storage. So I'll just get the answer from there. That'll be profit storage in the position of minutes minus k. This is a one-liner. I cut up a bit of code from the question before, sorry about that. This block inside works out the maximum amount of profit that we can make given we make the first cuts at k minutes. So the first chunk of video will be k minutes long, and then the rest of the chunk will be divided according to whatever was optimal, according to what we have already found. And so similarly, we can find what the maximum amount of profit will be, and that is by just simply saying max of potential profit, like that, right? And finally, by this stage, we are going to have the maximum amount of profit we can make given we have some minutes of videos. And the last thing I can do is I can just put this number back to the storage for future uses. And so the way I do that is by saying profit storage dot append, which is the way we add elements to the list of p, which is the maximum profit given minutes, sub-minutes, right? Finally, the last thing we have to do is, after we complete this loop, found maximum amount of profits for 0 minutes, 1 minute, all the way up to n minutes, because we want the final answer for n minutes, we're going to just have to return profit we get from n minutes, and that's just going to be calling profit storage at position n, which is just going to get the amount of money, the maximum amount of profit we can make if our videos is n minutes long. That function works. Hopefully that function works. And so if I call out max profit of, let's say 3 again, for what we have before, all right, I'm missing something. Oh yeah, I have to also include m there. That was my bad. I almost thought the code didn't work. And as you can see here, we get 7 again as before, right? If I, for example, have 10 minute worth of videos, 23 would be the maximum amount of profits I can make. More importantly, if I have 20 minute worth of video, and for example, I want to time this thing, it takes us 54 microseconds. I think that's a microsecond. That's microseconds. That is like, off the top of my head, I can't really do maths. I think that's 4 orders of magnitude quicker than what it was to call it recursively that before, which means that dynamic programming actually works, and this solution actually works pretty well.